4.2 is right triangle trigonometry. So first we talk about similar geometric figures. Remember, those are going to have the same shape. Specifically, it means that their angles are going to be equal and that their sides are proportional. Alright, then we're actually going to talk about our trig function. So some of y'all have already seen sine, cosine, and tangent, but then we have what we call the reciprocal functions. The reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So remember, reciprocal means just flip the fraction. It does not mean to the little -1, okay? So when it has that symbol, like if it said sine to the -1, that's actually an inverse, okay? So that is not the same as a reciprocal. So remember, reciprocal means to flip the fraction. The inverse means to switch the x and y. So they're really two different things, but a lot of times as math teachers, we use them improperly. We replace, sometimes we say the inverse when we're talking about the reciprocal. So just be careful on that. Alright, so when we're looking at a triangle here, we've got this angle of interest, which we're going to let theta be our angle of interest. Alright, and so if theta is my angle of interest, we're going to label our sides as opposite, adjacent, and hypotenuse. So opposite means across from. So the side that's going to be across from our angle that we're talking about is going to be our side that is opposite. Adjacent means next to, but it can't be the hypotenuse. So this side over here, when we're looking at theta, is our adjacent. And then remember, your hypotenuse is always the side that's across from the 90-degree angle in a right triangle. Now, if I told you we wanted to find sine of that angle, so we're going to put sine, which is abbreviated SIN, but it's still pronounced sine, of theta, sine is equal to the opposite over the hypotenuse. And so it's reciprocal cosecant, which is abbreviated CSC. So cosecant of theta is its reciprocal, so it's going to be the hypotenuse over the opposite. Cosine, that is abbreviated COS of theta, will equal our side lengths that are adjacent over the hypotenuse. And so its reciprocal secant, which is abbreviated SEC of theta, will equal the reciprocal, so the hypotenuse over adjacent. And then we have tangent. Tangent, that's abbreviated TAN of theta, is equal to our opposite over our adjacent. And so its reciprocal cotangent, abbreviated COT of theta, will equal adjacent over opposite. Now, a way to help you remember which ones go with which, some people have learned a thing called SOHCAHTOA. It helps you with the main three, the sine, the cosine, and the tangent, okay? So we can see that sine is opposite over hypotenuse, cosine, the C, is adjacent over hypotenuse, and tangent is opposite over adjacent. And then you just have to remember the reciprocal ones, meaning that we're just going to flip those fractions. Now, it's kind of tough sometimes. You'll have trouble remembering which one is the reciprocal of which. If you look at each group, each one of these has one title that starts with the letter C, okay? Now, tangent and cotangent are easy to remember because not only are they reciprocals, they're the cofunctions. But cosine and secant, sine and cosecant, y'all have a little more trouble remembering. So just remember, each one of these has one that has a C in it. So the two C's don't go together and the two S's don't go together. They each have to have a C and each have to have an S. All right, so let's talk about some triangles then. So the first triangle we're going to remember back to is our 45, 45, 90. And so I know it's been a while, but you talked about a 45, 45, 90 triangle back in geometry. And so back then, if you had the 45, 45, 90, you would say your sides are going to be in the ratio of x, x, and then x square root of 2. So for our purposes, we're going to let our x be a 1. So that means it's actually going to be 1, 1, and then 1 square root of 2, which is just square root of 2. So the first thing I need to do is to label my angles. And well, we can see the 90-degree angle, and so we know each of these is 45 degrees. Now remember, the angle on the side is going to go across from it. So across from the 45, and it doesn't matter which one, because if you notice, they're the same, because the same angle measures are going to have the same side measures, okay? So across from the 45, we're going to put a 1. Across from the other 45, we're going to put a 1. And then across from the 90, we're going to put that square root of 2. And so using that triangle, we can find the 6 trig functions of the angle of 45 degrees. So we just need to pick one of these 45 degrees to be our angle of interest. It doesn't matter which one. I'm going to pick this one because it's in the same position that the one we did above was. Okay, it's on that bottom left. It's what we would think of as in standard form, because remember, its vertex is at the origin and its initial side is lying on that positive x-axis. Alright, so we know that means that this side over here is opposite. The one at the bottom would be our adjacent, and of course across from the 90 is our hypotenuse. So for sine of 45 degrees, we know that it is equal to opposite over hypotenuse. Our opposite is 1. Our hypotenuse is the square root of 2. Now that would be our answer, except remember you can't have a radical in the bottom of a fraction. So we're going to multiply the top and bottom by that radical. And we end up with the square root of 2 over, and so the square root of 2 times the square root of 2, you can look at it two ways. It's equal to the square root of 4. Or you can say it's a square root of 2 squared. Either way, we end up with our answer, which is 2. So sine of 45 degrees is equal to the square root of 2 over 2. Now cosecant of 45 degrees, cosecant is the reciprocal of sine, and we can see that it's hypotenuse over opposite. Now we can use the fact that we can take sine and flip our fraction, or we can look at our hypotenuse and our opposite and simplify it from there. Doesn't matter. Either way, we're going to get the right answer. But guys, if I had to do work to find the sine of 45 degrees, which I did because I had to get rid of the radical, I probably don't want to flip the fraction because it's going to put that radical back on bottom, and then I'm going to have to undo it. So let's just go ahead and let's say our hypotenuse is a square root of 2 over our opposite is 1, and then we always reduce our fractions. So we get just the positive square root of 2 as our answer. Now for cosine of 45 degrees, we know it's adjacent of our hypotenuse. Our adjacent is 1. Our hypotenuse is a square root of 2. And so we know that from above, we're just going to get the square root of 2 over 2. Its reciprocal secant. So secant of 45 degrees is the hypotenuse, which is square root of 2, over the adjacent that's 1, which is also the square root of 2. Now, if you knew that sine and cosine were equal, then that meant cosecant and secant were also going to be equal because they're the reciprocals of them. And then the last group here, tangent and cotangent. Tangent of 45 degrees, tangent is opposite over adjacent. And 1 divided by 1, we need to reduce it, which is 1. Now, cotangent, I can say I'm going to do the reciprocal. So what's a reciprocal of 1? It's also 1. Or we could say that adjacent is 1, opposite is 1, and reduce it, and we still get the 1. Either way works to give us our answer. So there's our 6 trig functions of the 45-degree angle. So now let's look at the 30, 60, 90 triangle. So just like with the 45, 45, 90, you talked about the 30, 60, 90 triangle back in geometry. And you had learned their sides were x, x square root of 3, and 2x. Well, just like the other one, I'm going to let my x be a 1, so I'm going to have sides in the ratio of 1. 1 square root of 3, which is just square root of 3, and then 2 times 1, which is just 2. Now, the difference here, unlike on the 45, 45, 90, is we have two different angle measures here. And so you've got to decide which one is going to be your 30 degrees. Remember, though, your smallest angle is always across from the smallest side. So if we find our smallest side, which is this one, the smallest angle is going to be across from it. So 30 degrees is going to be here, which means 60 degrees has to be up here. And then we can see that across from the 30 degrees is going to be a 1. Across from the 60 degrees is that square root of 3. And across from the 90 is going to be the 2. And this is going to be true every time. Across from the 30 degrees, it'll always be 1 there. Across from the 60 is going to be the square root of 3. Alright, so let's look at the 30-degree angle as our angle of interest. So this is the angle that we're using. And so we know that our side that's opposite is over here. Adjacent's down at the bottom then. And the 2 is the hypotenuse. And so we can find our 6 trig functions of the 30-degree angle. So sine of 30 degrees is opposite over hypotenuse. Cosecant of 30 degrees is the hypotenuse over opposite, and make sure you always reduce your fractions if possible. Cosine of 30 degrees is adjacent over hypotenuse, and that is reduced. Secant of 30 degrees is hypotenuse over adjacent. Remember, now we can't have that radical on bottom, so we're going to multiply the top and bottom by it. So on top we have 2 square root of 3 over the square root of 3 times itself is just going to give us a 3. And we can't reduce it. Tangent of 30 degrees, tangent is opposite over adjacent. So again, we're going to have to get rid of that radical. And so we have the square root of 3 over 3. And then cotangent of 30 degrees, cotangent is adjacent over the opposite. And so reduce your fraction. And so cotangent of 30 degrees is equal to the square root of 3. Alright, and so we're going to use the same triangle, the 30, 60, 90, but this time we're going to look at it from the 60-degree angle. And so notice they changed the way our triangle's drawn, okay? So we still got the 30, 60, 90. Our sides are still in the ratio of x square root of 3, and 2x. And just like before, we're going to let x be 1, so it's 1 square root of 3, and then 2 times 1, which is 2. Now notice, remember, your 30 degrees, your smallest angle is across from the smallest side. Well, this is our smallest side, so that means this angle up here is our 30 degrees. And so this side is 1, which means this angle here has to be 60 degrees, and across from it will always be the square root of 3. And then the 90 degrees across from it will always be the 2 when it's a 30, 60, 90 triangle. All right. So our angle of interest this time is the 60-degree angle. And so if there's my 60 degrees, then I know that this side over here is opposite. The bottom's going to be adjacent to it. And our 2 is our hypotenuse. So let's find our 6 trig functions for 60 degrees. So sine of 60 degrees, we know that it is opposite over the hypotenuse. Cosecant of 60 degrees is your hypotenuse over opposite. Can't have the radical on bottom. And we can't reduce it, so that's our answer. Cosine of 60 degrees is adjacent over hypotenuse. We can't reduce that. Secant is hypotenuse over adjacent, and we need to reduce it. Tangent of 60 degrees is opposite over adjacent, and we need to reduce that. And then cotangent of 60 degrees is adjacent over opposite. Can't have the radical on bottom. And so we end up with the square root of 3 over 3. Now if you notice, when we did this 30-degree angles and we did the 60-degree angles, our answers look similar. They are the same numbers. Guys, we're still dealing with the same triangle. We're still dealing with the 1, the square root of 3, and the 2. It's just now the opposite side is a different side because we're looking at a different angle. Adjacent is a different side because we're looking at a different angle. So they should have the same types of numbers in them, just in different places. Alright, so using one trig ratio to find others. Example 4 says let theta be an acute angle such that sine of theta is equal to 5 over 6. It says evaluate the other trig functions of theta. Well, first thing is, what do we know about sine in terms of the side of the triangle? Remember that sine is opposite over hypotenuse. So I'm going to look at the triangle they gave us over here. We're going to pick our angle of interest. We don't know its value, so we're just going to put the theta there, okay? We don't need to know its value to find the trig functions of it. But I do know that the side opposite of my theta is going to be 5. And the hypotenuse is going to be 6. So how am I going to find the side that is adjacent? Well, we have a right triangle, excuse me, and we know 2 of the 3 sides. So we're going to be able to use Pythagorean theorem. So let me recap real quick. So the first thing we did is we chose our theta. We choose theta and label the triangle. And so now we're going to find the missing side. So remember Pythagorean theorem. It says a squared plus b squared equals c squared. And the only side that matters is the side C. And side C is always going to be your hypotenuse. So this is our C. So it doesn't matter which one of the remaining 2 we let be A or B. I'm going to go ahead and let A be the missing one, and B will be my 5. So when I do this, I don't know A plus B is 5 squared equals C, which is 6, and then squared. So a squared plus 25 equals 36. I'm going to subtract that 25. When I do that, I'm going to get a squared is equal to 11. Then we're going to take the square root. So we get a equals. We don't have to worry about the plus or minus because remember, it's the distance on the side of the triangle. It's a measurement, so it can't be negative. So we're just going to leave it as a square root of 11. Now, if it had been a number that we could break down the radical of, we would need to simplify it, okay? Alright, so now we know our 3 sides. We can fill in our sine, cosine, and tangent, or we can fill in our 6 trig functions. So remember the sine is opposite over hypotenuse. So opposite is 5 over the hypotenuse is 6. And we better gotten that one right because that was the answer that the one they gave us in the problem. Cosine of theta, cosine is adjacent over hypotenuse. Adjacent is the square root of 11. The hypotenuse is 6. Tangent is opposite over adjacent. So we get 5 over the square root of 11, but we can't have that radical on bottom. So 5 square roots of 11 over 11. Cosecant is a reciprocal of sine. So cosecant is going to be hypotenuse over opposite. So hypotenuse over opposite. Secant is a reciprocal of cosine. So it's going to be hypotenuse over adjacent. So hypotenuse over adjacent. Again, we can't have that radical on bottom. So we end up with 6 square root of 11 over 11. And then cotangent is the reciprocal of tangent. So it's going to be adjacent over opposite. So we get the square root of 11 over 5. And so if you didn't use the fact that it's just a fraction flip, then you can check yourself here. So are these two opposites? Are they reciprocals? These two and these two? They are. So therefore, we know we got our answers correct. All right, so to get an answer with a calculator. So it says to find the approximate values for each of the following. These are super easy, guys, but you got to be careful. You've got to remember to check your mode. If your angle is in degrees, you need to be in degree mode. If your angle is in radians, you need to be in radian mode. Remember, any time that you're literally going to type in, hitting the sine, cosine, or tangent button on your calculator, you've got to think about your mode. Now, these are all in degrees. How do I know? They all have a degree symbol. If they did not have a degree symbol, that means we're in radians, and you must change your mode. All right, so we're going to type in cosine. We're going to make sure we're going to go to mode, make sure it's in degrees, and then go back to your home screen and type in cosine of 30, hit enter, and it should give you approximately 0.866. Then you're already in degree mode, so type in sine of 45, hit enter, and it's going to tell you 0.707 approximately. We're rounding to 3 decimal places. Then we're going to type in tangent of 90 degrees, and it's going to tell us error. And that's because tangent of 90 degrees is undefined, and we'll talk about more on why later. Sine 15 degrees, hit enter, 0.259. Now, I don't have a cosecant button. And remember, cosecant's a reciprocal, not an inverse, so don't hit second sine. Since cosecant is a reciprocal of sine, this is the same as 1 over sine of 45 degrees. So as long as you're in degree mode, just type in 1 divided by sine of 45 degrees, and it's going to tell you approximately 1.414. And then cotangent is a reciprocal of tangent, so we're going to type in 1 over tangent of 45 degrees, and it's going to tell us 1. All right, so we have a right triangle that has a hypotenuse of 8 and includes a 36-degree angle. Find the lengths of the other two sides and the measures of the other two angles. So we've got a right triangle, and I'm going to draw it like all the others we've seen in standard position. Okay, has a hypotenuse of 8. So there's my right angle, so I know this is 8. And it includes an angle of 36 degrees. It doesn't matter which one we let be the 36. I'm going to put it down here. Now it wants us to find the lengths of the other two sides and the other two angles. So in the end, I need to know all 3 sides and all 3 angles. So I'm going to set up what I call an answer box. And so, well, first thing though, I need to label my angles and my sides. So I'm going to label my angles A, B up here, and C. Remember, angles are always labeled with capital letters. Now the side opposite of that angle has the same name, but it's going to be in a lowercase letter. So the side opposite of the angle A, which is at 36 degrees, is going to be side A. Opposite of angle B is going to be side B, and opposite of angle C, that 8, is our side C. So then I'm going to go ahead and set up my answer box. And so I need to know all 3 angles and all 3 sides. So I'm just going to list them all. Even though they already gave me some of them, that's okay. I can just go ahead and fill those in. But I know that once I get this box filled in, then I am finished. All right, so let's put in what they told us. Well, looking at what we've got, we know that angle A is 36 degrees, and they told me then that side C was 8. They also told us it's a right triangle, so we know our angle C is 90 degrees. And now we just got to find the rest of it. Well, let's see. We can find angle B, because remember, all 3 angles have to add up to 180. So 180 minus the other 2 added together. And that equals 54 degrees. So in your box here, make sure you label it in degrees. Remember, if you don't put a degree symbol, it's automatically going to be radians. Now, typically what we want to do, if it's possible, when we're solving for anything, we only want to use what was given, okay? Because let's say I made a mathematical error, and that was supposed to really be 55 degrees, or maybe it was supposed to be 44 degrees, and I put 54 degrees. If I use angle B to find side A or side B, and my 54 degrees is wrong, then those sides are going to be wrong as well. So if possible, stick with what they gave us. Stick with the 36 degrees. All right, so if I want to find side A, well, if I stick with what they gave us, they gave me this angle and they gave me the hypotenuse. If I want to find A is opposite. So opposite and hypotenuse is sine. So I could use the fact that sine of theta is equal to opposite over the hypotenuse to help me solve this. So I'm going to plug in what I know. I know the angle that I'm using is 36 degrees. Sine opposite was labeled A and the hypotenuse is 8. And so we're just going to solve this. So the first thing we're going to do is get rid of the fraction by multiplying both sides by the 8. That makes our fraction disappear. So we get A is equal to 8 times the sine of 36 degrees. And now I'll make sure my calculator's in degree mode. And I'm going to type that in. And when I do that, I get A is approximately 4.7. Now, since I know A and I know C, I can use Pythagorean theorem to find B. But if my side A is wrong, then my side B is also going to be wrong. But you still could do it. So what I'm going to do, though, instead is I'm going to go ahead and just use a trig function to help me as well. So we're still looking at the 36 degrees, but now side B is opposite, and they gave me the hypotenuse. I'm sorry, side B is adjacent. I misspoke. So they gave me I'm looking for the adjacent, and I know the hypotenuse. Adjacent, hypotenuse, that is cosine. So I'm going to use the fact to find on B, the fact that cosine of theta is equal to adjacent over hypotenuse. So I'm going to fill in what I know. Cosine, my angle is 36 degrees. My adjacent is labeled B, and my hypotenuse is 8. Multiply by the 8 to get rid of the fraction. And so we know the side B is equal to 8 times cosine of 36 degrees. And so side B is approximately 6.5. Now I didn't have to worry about labeling my sides only because they didn't give me a label before. If they'd have said the hypotenuse was 8 inches, then I would need to label all of my sides in inches. Alright, so I know all three angles. I've got all three sides. I know all the pieces of my triangle, so my problem is complete. And then the last one here. So it says, from a point 340 feet away from the base of the Peachtree Center Plaza in Atlanta, the angle of elevation to the top of the building is 65 degrees. Find the height of the building. It says, hint, find a ratio that will relate an angle to the sides, and it's usually the opposite and adjacent sides. All right, but it's not always, okay? But it's usually opposite and adjacent, so we're usually talking about tangent. Now, something I didn't mention when we did example 6 is, guys, even though there at the beginning I did know opposite and hypotenuse, I could have tried to use cosecant, but I didn't. I used sine because I have a sine button on my calculator, and therefore it's less work that I'm going to have to do when I go to type it in. So try to stick to your main three. Stick to your sine, cosine, and tangent when you're working these type of problems. All right, so back on example 7, though, they were nice. They drew it for us. But if they didn't, we know a building is going to stand straight up. Whoops, let me turn my pen on. Let me try to get rid of that extra stuff there. Okay, so we know a building is going to stand straight up. So if they didn't give me this picture, I would draw a building. And it says, was it from a point 340 feet away from the base? So from the base, we would go a distance, and we would label that the 340 feet. It says the angle of elevation to the top of the building. So remember, angle of elevation is when you look up. So therefore, that would be this angle here where we're looking up to the top of the building, would be our 65 degrees. But they were nice. They drew it for us, so we didn't have to do that. All right, so it wants us to find the height of the building. So we are after this side here, the height of that building. Well, again, like the last one, let's look at what they gave us. We don't have to find all the pieces. It only wants that one side this time. But they gave us our angle, and to this angle, we're looking for opposite, and they gave us this side, which is adjacent. So if we're looking for opposite, and they gave us adjacent, opposite over adjacent is tangent. So we're going to use tangent to help us find this. So like the last one, let's fill in what we know. So we get tangent of our angle, 65 degrees, equals opposite is what we're looking for. So I labeled it an H over the adjacent, which is the 340. Now we're just going to solve for h. So we're going to multiply by the 340. And guys, that's going to be your first step on all of these, is if you got a fraction, multiply by the denominator. Even if this had been flipped, if it had been a 340 over h, then we would still multiply by the denominator, and then we would end up having to divide again to get the denominator, or get the h by itself. But this one, the h was on top, so we don't have to worry about that. So the height of the building is equal to 340 times tangent of 65 degrees. And so let's plug that in our calculator, and we'll find that our height is approximately 729. I know there were some decimals, but I didn't write it down, so I'm just going to leave it at that. And then remember, you got to label height. The distance is measured in feet, and that's because the 340 feet.